Welcome to our in-depth journey into the heart of one of Earth's most powerful natural forces, earthquakes. In this video, we'll uncover the science behind these tremors. From what causes them deep within the Earth to the way they shape our landscapes and cities. Get ready to explore the secrets beneath the surface and learn how science helps us understand and prepare for these dynamic events. Earthquakes are one of nature's most awe-inspiring phenomena, often arriving without warning and leaving powerful changes in their wake. They're a reminder of the restless energy lying beneath our feet, the shifting of immense rock plates that make up the Earth's crust. Imagine for a moment that the ground beneath us isn't as solid as it seems. Instead, it's more like a giant jigsaw puzzle of tectonic plates. Massive slabs of rock floating on a layer of semi-fluid material known as the mantle. These plates are constantly in motion, though at an extremely slow pace, driven by the heat coming from Earth's core. The process begins deep within the Earth, where temperatures and pressures are intense enough to keep the rock beneath our feet in a semi-molten state. The slow flow of this material creates a gradual movement of tectonic plates. These plates interact in different ways. Some move apart, others slide past each other, and some collide head-on. Each interaction creates stress along the plate boundaries. And as these stresses build up, something eventually has to give. When it does, the energy stored within the rocks is released as seismic waves, shaking the ground above. This release of energy is what we feel as an earthquake. Earthquakes happen most frequently along fault lines, which are cracks in the Earth's crust where plates meet or slide past one another. Some of the most famous fault lines, like the San Andreas Fault in California, have become infamous for the number of significant earthquakes they produce. However, fault lines exist all over the world, which is why earthquakes can occur almost anywhere, though they're most common in regions known as seismic zones. Like the Ring of Fire encircling the Pacific Ocean, when the stress on the rock reaches its breaking point, seismic waves ripple out from the point of release, known as the focus, and spread throughout the surrounding area. The point directly above the focus on the Earth's surface is called the epicenter, and this is often where the earthquake's effects are felt most intensely. These seismic waves come in different forms. Primary waves, or P waves, are the fastest, traveling through both solid and liquid layers of the Earth. They're followed by secondary waves, or S waves, which are slower but more powerful. The surface waves, which cause the ground to shake violently, come last and are usually the ones responsible for the most visible destruction. The intensity of an earthquake is measured on a scale, most commonly the Richter scale or the moment magnitude scale. While the Richter scale is widely known, the moment magnitude scale has become more prevalent because it provides a more accurate measure of the earthquake's total energy. The magnitude of an earthquake doesn't always correspond to the amount of damage it causes. Sometimes, a high-magnitude earthquake in a remote area may go relatively unnoticed, while a smaller earthquake in a densely populated region can cause significant destruction. Despite their potentially destructive power, earthquakes also play a role in shaping our planet. Over millions of years, the movement of tectonic plates has created mountain ranges, deep ocean trenches, and the continents as we know them today. Earthquakes contribute to the ongoing process of geological change, a cycle of building up and breaking down that has been occurring since the Earth's formation. In our modern world, science and engineering have allowed us to better understand and prepare for earthquakes. Seismologists study patterns of earthquakes, monitor fault lines, and use sophisticated technology to detect the tiny tremors that often precede a larger event. This work has improved early warning systems, especially in regions like Japan and California, where earthquakes are a regular part of life. Engineers design buildings and infrastructure to withstand seismic forces, helping to reduce the damage and save lives when earthquakes strike. Earthquakes are a powerful reminder of the dynamic nature of our planet. They connect us to the forces that shape the Earth's landscape over millions of years and continue to do so today. Although we can't predict exactly when or where the next earthquake will strike, our understanding of their causes and effects brings us closer to adapting and living safely alongside these incredible natural events.